This is my second video in my series explaining the stack machine from Nand2Tetris. In this video, I will walk through the stack arithmetic test programs, SimpleAdd and StackTest. I'm going to walk through each program twice. The first time in the virtual machine emulator, and the second time I'll explain that program using index cards like I did in my previous video. To start, I'm going to go into my Nand2Tetris folder. I'm going to go into the Tools folder, and then I'm going to open the VM emulator. I'm going to set the animate setting to program and data flow, and then I'm going to load the test script SimpleAdd vme.test, and this is going to be in folder 7, stack arithmetic, SimpleAdd, and then SimpleAdd vme.test. So now that I've loaded the test script into the VM emulator, I need to click on the single step button once in order to see the program. So now we have the program, and I can see that we have 3 commands. We have push constant 7, push constant 8, and then add. So I'm going to click on single step once to run the first command, and we see we've just pushed constant 7, and so now on the stack here on the left side, we have a 7 in the stack. I'm going to click on single step again, and now we've pushed constant 8 onto the stack, and so now we have an 8 in the stack. And then I'm going to add the top 2 values in the stack together in our next command. So I'm going to click on single step. And so we're going to take the 8, we're going to take the 7, we're going to add them together to get a 15, and we're going to return that 15 to the top of the stack. So now that I've walked through this example, I'm going to explain it again, but this time using index cards like I did in my previous video. So first I'm going to restart the script, and then I'm going to open up a video that I made in advance. And so everything I will show in this video right here on the right corresponds to what is happening in the stack over here on the far left. So I'm going to start with my video on the right. So first I push a constant 7 onto the stack, and then we can see the same thing happening here on the left. So this 7 in the stack corresponds to this 7 on this index card right here in the video on the right. And then next I'm going to push the constant 8 onto the stack. So we can see that 8 there. And then on the left I will be doing the same thing. So this 8 corresponds to this index card with the 8 written on it. And then I am going to add the top 2 values in the stack on the right. So I'm going to take a card with add written on it, flip it over with the result, take all of those cards, and then staple them all together to show that they've become a single. We treat that pile of cards like it's a single card. And so that's the end of that video. And then on the left, I'm going to add the top 2 values in the stack. So we take the 8, we take the 7, we add them, and then we return that 15 to the top of the stack. And so let me just go back in my video here. So we have that 15, and that corresponds to this 15 here in the stack. And so with my video on the right, I wanted to show that that operation of adding the top 2 values and then returning a single value. And so that explains why in the stack here on the left, that explains why the 7 and the 8 disappear and why we're only left with a 15. And then I also wanted to mention that in my demonstration on the right, I had that card with add written on it, and then I had the result of the operation written on the back. I just want to say that that's just something I made up for my explanation. I thought it was easier to understand and explain it using that. But there's no add card, there's no function cards here in the stack on the left. So just keep that in mind as I continue to go through the next example. So now I'm going to walk through the second example, stack test. So first I want to make sure I have the animate setting to program and data flow. Then I'm going to load stack test vme.test, and this is going to be in folder 7, stack arithmetic, StackTest, StackTest vme.test. I'm going to load that, and then we can see the instructions. So starting with the first command, we have push constant 17. So I'm going to push constant 17, and then we can see a 17 pop up in the stack. We push constant 17 again, and then we see another 17 in the stack. We check if they're equal. And since they are equal, we return a -1 to the stack. Then we push a constant 17, push constant 16, check if they're equal. And they're not equal, so we return a 0 to the top of the stack. All right, so I'm going to start on the right in my video, and then I'm going to follow along in the virtual machine emulator on the left. So first, I push a constant 17, so we do the same thing on the left. Then I push a constant 17 on the right, and I do the same thing on the left. Then I check if they're equal, and they are equal, so we get a -1 on the right, and then I staple them on the right, and I do the same thing on the left. Then on the right, I push a constant 17, and then on the left, I push a constant 17. Then on the right, I push a constant 16, and then on the left, I push a constant 16, and on the right, I check if they're equal. They are not equal, so we get a 0 on the top of the stack, which I take all the index cards and staple them together. And then we see the same thing on the left, where we check the 16, we check the 17, we check if they're equal, and they're not, so we get a 0, and so that's where we get the -1 and the 0. And so I'm going to skip the rest of this program, or most of this program, down to line 26, because it's more or less the same. And if you've understood everything up until now, the rest of these should make perfect sense. So I'm going to switch this to program and data flow, and then I'm just going to work my way through the program down to line 26. So at line 26, we have 32,766 and 32,766 at the top of the stack. We're going to check if one is greater than the other, and this is going to be false, so we are going to get a 0. And so we get this 0 here. And so this is where I'm going to pick up again, explaining this line by line, because there's a few things in this part of the program that I want to discuss. All right, so now I'm at line 27 of our program. And then I'm going to push constant 57. So now we see the 57 pop up at the top of the stack. Push constant 31, 53, add the top two values in the stack. So we take the 53 and the 31 and we add them together. And then the command returns an 84 to the top of the stack. Push a constant 112. We subtract the top two values in the stack. And this command returns -28 to the top of the stack. And then in line 33, we have neg, which is a unary operation, so it only takes one input. Up until now, we've only seen binary operations, which always take two inputs, but neg takes only one input, so we can see how that works, where we take the -28, we get a +28 back, and we return that +28 to the top of the stack. And then in line 34, we have an AND operation, and normally AND operations only work with Boolean operators, which are -1 and 0. But since we are at a low-level language, the virtual machine can't tell it doesn't know the difference between types. So in a high-level language, trying to do something like this would give us an error, but since this is a low-level language, we can technically do this, even though it's not really correct, and you would never want to do this, but we can, and we'll see that we get an unexpected result. So we take 28, we take 57, and then we happen to get back at 24. And I think that students will find that as they complete this project, they'll figure out why that is. But that's just something I want to know quickly, that we can take commands and use the wrong types as inputs. So in line 35 now, we have a push constant 82. So we're going to push an 82 onto the stack. And then in line 36, we're going to take an OR of 24 and 82. And again, we are taking a logical command with an input of two integers, which this isn't something that we should ever do, but we can see what happens here, and it's a result that we don't expect. So we take the 82, then we take the 24, and then we happen to get 90 out. And then again, this is another thing that I think students, once they complete this project, they'll figure out why that is. And then in line 37, we have our only other unary operation, which is not, and again, this is supposed to only take in Boolean values as inputs, but here we happen to see it, we're taking an integer as an input for this command. So we will see what that outputs. So we start with a 90 and we get a negative 91 back. And so now we have a negative 91 on the top of the stack. All right, and then next I will be reviewing these this part of the program, but with index cards. So now I've reset my StackTest program and I worked my way down to line 27 of the program. And then on my right, I have my video explanation of these commands. And so to start, we have this 0 here at the top of the stack, which is the result of comparing 32,766 to 32,766. And then we see if one is greater than the other, and we know this is false, so that is where the 0 comes from. And then on the right, I have this same 0, which corresponds to that 0. And then I opted not to write up all of these other values that are in the stack, because that would take up a lot of the space that I had, and it wouldn't really add anything to the video. So that's why I only have this 0 right here. So start this video, and we can see that I push a 57. Let me check the speed of this video and make sure it's the normal speed. All right, there it is. So we push a 57 on the right, and then we push a 57 on the left. Then on the right, I push a 31. And then on the left, I push 31. On the right, I push a 53. And then on the left, I push a 53. On the right, I add the top two values in the stack. So those 31 and 53 added together is going to be 84. So I take all of those cards and staple them together. And then I do the same thing on the left. Oh, let me set this program in data flow again. I forgot to do that. And then, all right, let me just see where I am. On the right, we're going to push a constant 112. So on the right, we push constant 112. We do the same thing on the left. Then we subtract the top two values on the right. So 112 minus 84 is going to be negative 28. Then on the right, I take all of those cards and staple them together. Pause that. And then on the left, we take the 112 and we take the 84 and we subtract them. So we get a negative 28 on the top of the stack. And then on the right, we're going to take the negative value of negative 28. So here I come in with a card with neg written on it. Looking around for where it is. I come in with a card with neg written on it, and then I flip it over, put it on the top card, and then I have the I get positive 28. So the negative value of negative 28 is positive 28. And so then that's how I like to represent it with index cards, where for unary operations, I just take the card with the function written on it, I put it down on the top value, and then I flip it over with the output. So that's where that negative 28 comes from. And then I could do the same thing on the left. All right, and then I take the and on the right. All right, there it is. And then I take all of those cards and staple them together. So that's where the 24 is. And then I do the same thing on the left. So we take the 28, we take the 57, we check take the and value, and it's going to be 24. And then on the right, again, I push a 28, I push an 82. And then on the left, I'm going to push an 82. And then on the right, I take the OR value of these two top values. So I take the OR of 24 and 82. All right, so there it is. I take the OR of 24 and 82, and I get a 90 back from that. I can do the same thing on the left. And then on the right, I take the naught of 90, and then I get a negative 91. And again, not is a unary operation, so I only put that on the top value in the stack and flip it over. And then do the same thing on the left. All right, so now that concludes this demonstration. I just want to point out that this -91 here corresponds to that -91 right there. That 0 right here corresponds to that 0 right there. And of course, I have all these other values in the stack, which I don't include in my video because that just take up a lot of space and time to do. In my next video, I'm going to be talking about the implementation of the stack machine.